Imagine a world that, by all logic, should not exist. A planet orbiting a star that, for all intents and purposes, is dead. Our universe, vast and wondrous, often defies our neatest scientific models, presenting us with phenomena so bizarre, so utterly improbable, that they force us to rewrite the cosmic rulebook. We've spent decades searching for planets like Earth, orbiting sun-like stars in the so-called Goldilocks zone, not too hot, not too cold. But what if the most mind-bending discoveries weren't in those familiar, comforting places? What if the real cosmic shockers are found in the most extreme, desolate corners of existence, defying every expectation we hold about how worlds are born? Today, we're plunging into the ultimate cosmic paradox: planets that shouldn't be, orbiting the corpses of stars. Get ready to have your understanding of planet formation turned inside out, because we're about to discover the impossible. For centuries, our understanding of planets was simple. They formed in the swirling disks of gas and dust around young, vibrant stars, gradually accreting material until they grew into the magnificent worlds we see. This elegant ballet of gravity and matter gives birth to everything from rocky terrestrial planets to gas giants. But then, in 1992, just as the hunt for exoplanets was truly beginning, scientists made a discovery that shattered this conventional wisdom into a million pieces. They didn't find a planet orbiting a star like our sun. They found 2, then 3, orbiting a pulsar. A pulsar isn't just any star. It's a neutron star, the hyperdense, rapidly spinning core of a massive star that violently exploded in a supernova. Imagine a star many times more massive than our sun, collapsing under its own gravity until it's squeezed into a sphere only about the size of a city. This stellar remnant spins hundreds of times per second, emitting focused beams of radiation that sweep across space like a cosmic lighthouse. These are the most extreme objects in the universe, second only to black holes. The surface gravity is immense, the magnetic fields are billions of times stronger than Earth's, and the radiation environment is unimaginably hostile. The very idea of a planet forming, let alone surviving, in such an environment is ludicrous. A supernova is one of the most destructive events in the cosmos, an explosion so powerful it can outshine entire galaxies for a brief period. Any planets orbiting the progenitor star would be instantly vaporized or flung into interstellar space. The protoplanetary disk, the very cradle of planet formation, would be utterly obliterated. So, when astronomers Alexander Walskson and Dale Frail announced the discovery of 3 planets orbiting the pulsar PSRB 1257+12, the scientific community was stunned. Not only were these the first exoplanets ever confirmed, but they were planets that, by all known theories, absolutely should not exist. These pulsar planets were no small feat of detection. PSRB 1257+12 is located about 2,300 light-years away in the constellation Virgo. Walskson detected tiny, regular variations in the timing of the pulsar's radio pulses. These minute deviations, consistent with the gravitational tug of orbiting bodies, betrayed the presence of 3 planets. The smallest, roughly the size of our moon, the second a few times more massive than Earth, and the third, the largest, about 4 times Earth's mass. They orbit incredibly close to their dead star, with periods ranging from 25 to 98 days. The mystery was profound. How could these planets have formed? The prevailing theory of planet formation, called core accretion, relies on a serene, gas-rich disk around a young, stable star. A pulsar offers none of these conditions. It's a relic of cosmic violence, its surroundings scorched by a supernova. Scientists have proposed several fascinating, albeit speculative, scenarios to explain these impossible worlds. The leading hypothesis is what's known as second-generation formation. In this model, the planets formed after the supernova. Imagine the star exploding, ejecting vast amounts of material into space. Over time, some of this ejected material, heavy elements and dust, doesn't escape entirely. Instead, it falls back towards the now collapsed core, forming a new, albeit temporary, accretion disk around the nascent neutron star. This fallback disk would be very different from a typical protoplanetary disk, hotter, more energetic, and far less massive. But within this incredibly hostile environment, perhaps through rapid accretion or even gravitational instability within the disk, these resilient planets managed to clump together, slowly but surely. Another, less likely, theory posits that the planets did exist before the supernova, somehow surviving the catastrophic explosion. This would require an almost unbelievable set of circumstances, as the supernova's shockwave and intense radiation would likely sterilize and destroy anything in its path. Even if they weren't directly hit, the sudden loss of the star's outer layers would drastically change the gravitational forces, likely flinging any remaining planets out of orbit. Yet another possibility is planetary capture, where rogue planets, perhaps ejected from other systems, were gravitationally snared by the pulsar. While possible, the probability of capturing 3 planets into stable, nearly circular orbits around a pulsar is astronomically small. The existence of pulsar planets fundamentally reshapes our understanding of cosmic resilience and the sheer diversity of planetary formation. It tells us that planet formation isn't a process exclusive to the gentle nurseries of young, healthy stars. It can happen in the most extreme, violent, and unlikely corners of the universe, even in the aftermath of a star's death. These worlds are not only a testament to the universe's creativity, but also a challenge to our assumptions about life. While the surface of a pulsar planet would be incredibly harsh, constantly bombarded by high-energy radiation, with no sunlight in the traditional sense, who is to say what forms of life, if any, could adapt to such alien conditions, perhaps drawing energy from geological activity or the pulsar's intense magnetic fields? These impossible planets around PSR B1257 plus 12 remain unique. While other neutron stars have been found with orbiting objects, these 3 are the most well-characterized and definitive examples of planets born from stellar death. Their very existence forces us to confront the limits of our knowledge and expand our imagination. They are a profound reminder that the cosmos is far stranger and more inventive than we could ever dream, constantly unveiling new wonders that push the boundaries of what we thought possible. And if planets can rise from the ashes of a supernova, what other cosmic miracles lie hidden, waiting to be discovered, defying every rule we thought we knew?